In engineering applications, a metallic disc is used to design rotating machinery parts. Transferring of rotational kinetic energy between different parts of a machine depends upon moment of inertia of the disc. In today's video, let us obtain expression for moment of inertia of a uniform disc. Uniform disc has same mass per unit area in its composition. It has negligible thickness compared to its diameter. Let m equals to mass of the disc, r equals to radius of the disc, cross-sectional area of the disc equals to pi r square. Then surface density equals to mass upon cross-sectional area equals to m upon pi r square. Now considering this circular disc is consisting of large number of concentric rings of increasing radius. So smallest radius of the ring is equals to 0 and largest radius of the rings equals to r. Now select one of such rings and let us call it as an elemental ring. Let dr be the width of the ring, dm equals to mass of the ring, and r equals to average radius of the ring, average of inner radius and outer radius, that is equals to r. So r equals to average radius of the ring. Now area of the elemental ring equals to circumference of the ring multiplied by width of the ring. Therefore dA equals to 2 pi r multiplied by dr. Since surface density equals to mass upon cross-sectional area, therefore sigma equals to dm upon 2 pi r multiplied by dr implies dm equals to sigma into 2 pi r multiplied by dr. To find moment of inertia of the given disk, we need to frame a formula. For that, we have taken here elemental ring. Now moment of inertia of elemental ring equals to mass of the ring multiplied by the square of radius, that is dm r square. But dm equals to sigma into 2 pi r multiplied by dr. Therefore moment of inertia of the ring equals to sigma into 2 pi r multiplied by dr multiplied by r square. So finally moment of inertia of the ring equals to sigma into 2 pi r into r square into dr. This is nothing but moment of inertia of elemental ring. Since we have obtained the moment of inertia of the ring, so that we can find out moment of inertia of the disc. Our aim is not to find out moment of inertia of the ring. Our aim is to find out moment of inertia of the disc. Now the smallest ring is possible with radius equals to 0. Therefore minimum value of the radius of the ring is r equals to 0 and maximum value of radius for the ring is equals to r equals to capital R. Therefore the radius of the ring varies from 0 to capital R. Now our aim is to find moment of inertia of entire disc. To find moment of inertia of entire disc, integrating above expression between limits 0 to r. Therefore moment of inertia of disc equals to integration between the limit 0 to r sigma 2 pi r r square with respect to r. Here integration with respect to r. Therefore moment of inertia of the disc equals to integration 0 to r sigma 2 pi r into r square with respect to r. Now sigma is constant, 2 pi is constant. Therefore, taking 2 pi sigma out of the integration, now 0 to r, and r into r square, that equals to r cube with respect to r. This is equals to 2 pi sigma, integration of r cube is nothing but r raised to 4 upon 4, and limits are 0 to r. This is equals to 2 pi sigma r raised to 4 upon 4 minus 0. So this is equals to 2 pi into sigma r raised to 4 upon 4. But sigma equals to m upon pi r square. So putting the value of sigma here, into r raised to 4 upon 4, cancelling r square, cancelling pi, cancelling 2, we get here half m r square. Therefore, moment of inertia of the disk, entire disk, equals to half m r square, or we can also write as a m r square divided by 2. So, moment of inertia of the disk about an axis, this is the axis of rotation. So, moment of inertia about an axis perpendicular to the plane of the disk passing through the center of the disk is given by I equals to m r square upon 2. It can also be called as a moment of inertia of the disk about the center of mass is equals to m r square upon 2, m r square divided by 2. So friends, how was the presentation? Did you like the presentation? Please let me know through the comments in the comment box. In Hindi it is said that जब आप काम करते हो और आपको शाबाशी मिल जाती है तो आप काम और बढ़िया करते हो. So to do the work more better, to present the physics in more simpler way, I want shabashi from you. So I hope you will write down your comments in the comment box. Meet you again with another topic. Till then, wish you good luck, all the best. Thanks for watching this video. Bye bye. See you.